Okay, so today we're going to start chapter 5, and we're going to start off with inverse functions. Okay, so what is an inverse function? The inverse of a function is found by interchanging the entries in each ordered pair. In other words, we're going to switch our x's and our y values. So for the top row, this is our function f of x. These are coordinates that are in f of x. Notice we have negative 27, negative 3, negative 8, negative 2. This right here is the symbol for an inverse function. And if we look at it, notice that instead of negative 27, negative 3, we switched our x's and our y's, and we now have negative 3, negative 27. Instead of negative 8, negative 2, we now have negative 2, negative 8. This coordinate is negative 1, so it doesn't look like we switched it, but we actually did. And same thing for all of these. The last one is 8, 2 for the function, so the inverse is 2, 8. Okay? So if a function is one-to-one, and that is important to have a one-to-one function, then for each x in the domain of f, there's exactly one y in the range, and no y in the range is the image of more than one x in the domain. So what does that mean? That basically means, if we look at these diagrams right here, right? If we look at this over here, here's our domain and here's our range. Each x value has exactly one y value, so this is a function. But if we go in reverse, you notice that every y function, or every y coordinate has exactly one x. So here, this is one-to-one, right? Every x has one value, every y has one value. If you look over here, this is a function because every x has exactly one value, even though it's the same value. But if we look at it in reverse, this is not one-to-one because the y has two values for x. So this is a function, but it is not one-to-one. Okay? Over here, x has two values, so it's not even a function. So do we care if it's a one-to-one? No, because it has to be a function to start off with. Okay? In order for a function, or in order for the inverse of a function to be a function itself, the original function must be one-to-one. So we can make an inverse out of any one of our functions that we have, but it's not, the inverse is not a function unless it's one-to-one, and we can do a horizontal line test in order to figure out whether or not it is one-to-one. So you guys remember the vertical line test, right? Where we check to see whether or not the function or the graph is a function. Now we're going to check to see if the inverse would be a function. So the horizontal line test is where if every horizontal line intersects the graph of the function once, then the function is one-to-one. So here's our function. We know that it is a function because it would pass the vertical line test. And if we do the horizontal line test, you notice it only goes through the graph once. So this is one-to-one. Over here, this is a function, right? It would pass the vertical line test, but if we did a horizontal line test, it would not pass, which means this is not one-to-one, so the inverse is not a function. And we're going to go over how to find inverses at the end, but for now, know that if it doesn't pass the horizontal line test, the inverse is not one-to-one. Okay? Okay, so looking at this next portion, we have a theorem, which is kind of like a rule. You guys probably had theorems when you were doing geometry. And this says an increasing, decreasing function is one-to-one. In other words, if we look at it from left to right, it is increasing, right? If we had it in the opposite direction, that would work also. So anything that's increasing or decreasing is going to be one-to-one. This, on the other hand, is decreasing and then increasing, right? And this is not one-to-one. So if we're just completely increasing or if we're completely decreasing, it's going to be one-to-one. If it's doing both, it's not going to be one-to-one. And what do you notice about these two graphs? What can we say about graphs that are always going to be either increasing or decreasing on its own? These are odd functions and these are even functions. So even functions are not one-to-one, odd functions are. Okay? This part right here, I'm going to go over really quick, but not really necessary for your test. But if this makes sense for you and you want an extra you want some extra knowledge, then go ahead and copy this down. Otherwise, you can just listen, and hopefully this will make sense. And if it doesn't, don't worry about it. So an inverse function of f undoes whatever f does. So here's an example. G of x is equal to 1/2 x. F of x is equal to 2x, right? If I plug this function into here or this function into there, we should just, and everything should simplify out, and you should just get x. So the inverse of f is denoted by f of -1. In this case, -1 is not an exponent, right? So when you have a function and its inverse, the domain of f is equal to the range of the inverse, and the range of f is equal to the domain of the inverse. So if I do a composite and I plug in f of x into f prime, the inverse of f, everything cancels out, you should get x. If I plug in the inverse of the function into the function, everything should cancel out and equal to x. So if we look at this information right here, right, we know that g of x is equal to x cubed, and the inverse of g of x is equal to the cubic root of x. So when I plug one into the other, everything should cancel out. Well, let's try this out. I'm going to do g of the inverse of g of x, right? So I'm going to take this right here, and I'm going to plug it in here. So I have the cubic root of x raised to the 3rd power, right? In other words, x to the 1/3, that's what the cubic root is, raised to the 3rd power. What's 3 times 1/3? Well, 3 times 1/3 is equal to 1, so our answer is x, and this works. I can do it in reverse also, right? And I can take this and plug it into here. And so in that case, I'd have the inverse of g of x. And I would get the cubic root of, in this case, x cubed, which is the same thing as x cubed raised to the 1/3 power. And 3 times 1/3 is equal to 1. So this does work. Okay, once again, if this did not make sense, then you can go ahead and skip this part. It's not as important, but hopefully this made sense to you. Here are some problems to try on your own. There's 2 problems, so pause the video right now and go ahead and give it a try. I'm going to go ahead and solve for this. So I'm going to plug this into here, and I get 1/3 times 3x. What's 3 times 1/3? That's equal to 1, and we're just left with x. So this works. We're just checking to make sure these are inverses of each other, all right? So this one, I'm going to plug in, let's plug that in here. So I get 1/2 2x plus 3 minus 3. Well, 3 minus 3 cancels out, and I have 1/2 times 2x. Well, what's 1/2 times 2? That's equal to 1, so we're left with just x again. Okay? Okay, so now for the important part of the notes for today, which is how do you find the inverse of a function? Once again, f to the -1st means that we are looking for the inverse, and you do need to do the inverse notation. So here are your steps. We're going to interchange the variable x and y. This defines the inverse function implicitly. And then, if possible, solve for y to obtain the explicit form of f to the -1st power. Check, and that's what we just did, was checked by plugging one into the other. We're going to do actually it this way. So I have f of x. I'm going to change f of x into y, right? And then from here to here, I'm going to switch my x's and my y's. So notice this is y equals 2x plus 3. We're going to switch it to x equals 2y plus 3. Now, that's how we did it to get an implicit function. I actually want to solve it explicitly, which means solve for y. Okay, so now we have, over here we have x is equal to 2y plus 3. I'm going to move 3 to the other side, and I get x minus 3 is equal to 2y, right? And then I have to divide both sides by 2. Right? I have to divide everything on both sides by 2. So here I get x divided by 2, which is the same thing as 1/2 x. And then here I get 3/2. I can leave that as long as it's simplified. And I can change that to y. But I know already that this is going to have to be written in inverse function format. So I have to change that y to what? I have to change it to the inverse function of x. And yes, if you do not do that, I will take points off. Okay? So take a moment to write down these notes and then give this problem here a try. Okay. I'm going to move this up. Actually, let's move this out. Here we have f of x is equal to 2x plus 1 over x minus 1. First thing I'm going to do is switch it to y equals 2x plus 1 over x minus 1. I'm going to then switch my x's and my y's. So wherever there's an x, I'm going to change it into a y. Whatever there's a y, I'm going to change it to an x. Right? And now, in order to get rid of that denominator, I'm going to multiply both sides by y minus 1. So this cancels out. And on this left side, I have, I'm going to distribute. I get xy minus x is equal to 2y plus 1. Notice I have two y's. How do I make 2 y's equal to 1 y? Well, I'm going to move all the y's to one side. I'm going to, in this case, let's go ahead and add x to this side, right? And let's subtract 2y. So this cancels out, and this cancels out. And I am left with xy minus 2y is equal to x plus 1, right? I moved everything with a y to one side, and I moved everything without a y to the other side. Now, how do I make these two y's equal to just one y? Well, we use factoring. So I can factor out a y out of both of these. So I get y times, and xy divided by y is just x. And then negative 2y divided by y is just negative 2, and that's equal to x plus 1. And now, in order to get rid of this, I can divide both sides by x minus 2. So I have y is equal to x plus 1 divided by x minus 2. See? And then once again, I have to change this to the inverse of. Make sense? One last example, and then we are done. Okay? So let's look at the last example. And I'm going to have y is equal to the square root of x minus 2. Once again, I'm going to switch my x's and my y's. So I have x is equal to the square root of y minus 2. How do I get rid of that square root? Well, if I square this side, I'll get rid of the square root. But whatever I do to this side, I have to do to this side also. So now I'm left with x squared is equal to y minus 2. I'm going to add 2 to both sides, and I get x squared plus 2 is equal to y, which is our inverse of our function. So knowing how to get the inverse of a function based off of an equation is going to be the most important part of this lesson. That's what you're going to be tested on when I get back. So hopefully this made sense. If not, feel free to text me, or you can go see Mr. Bethel and ask him for help, or go to the Rose Lab today. Okay, thank you.